There's yet another home-built radio on a breadboard. But what is so special about this? Well, it is easy to build as it only needs few components. Mainly an RDA5807 Single Chip FM receiver and a WIO Terminal. This is a small development board with a powerful ARM CPU running at 120 MHz, a 320 by 240 pixel LCD display, small joystick and 3 push buttons. Thanks to its 40-pin connector on the backside, it can easily be used in all sort of electronic projects. This makes it the perfect device to build a small FM receiver. I'm going to show you how to do that in this video, so stick around. According to the confidential datasheet, which can actually be downloaded from everywhere, this chip has a wide receive frequency range from 50 up to 115 MHz. So you can also listen to FM stations in Russia and Japan. These use FM frequencies below 88 MHz. And it can also be listened to interesting FM communication outside the public broadcasting bands, like that of firefighters or the police. The 5807 needs only a minimum of external components. That's good for us, but it comes in an SMD package and these are not really tinkering friendly. However, breakout modules are easy to find and also cheap, so I got myself one. The modules have a 2 mm raster, thus they do not match the 100 mm raster of a breadboard. The solution is to solder one on a piece of perf board. When doing so, put on some flux and then drag solder bridges between the pins and the notches of the module. Now it fits perfectly. After all, make sure that there are no shorts between the joints. Life could be a bit easier with the Grove I2C FM receiver module. This fits directly to one of the WIO's Grove ports. Unfortunately, it is currently out of stock, but maybe it is available again now as you watch this video. Here I've put everything together on a breadboard. I connected the terminal's power and I2C pins to the 5807. It is designed to drive a headset, but with an LM386 amplifier I can now use a decent loudspeaker. And with two of these we can have stereo sound. Of course, other more powerful amplifier ICs can also be used there, but the advantage of the LM386 is that it runs on supply voltages between 4 and 12 volt and therefore can be supplied by the 5 volt pin. And I almost forgot to mention that we need an antenna. Optimal length is about 70 cm or 27 inches. Okay, and now let's see if we can get some noise out of it. We now need to write the appropriate values into the register through I2C. This looks complicated, but luckily there are two Arduino libraries available for that. This library here supports other receiver chips as well, and this one is for the 5807 only. But it gives more control over the chip, so I'm going to install it now. Under Examples I open the circuit test sketch and upload it to the WIO Terminal. The Arduino and the WIO Terminal are based on the same API, so the program runs without any problems. And now it scans through the FM range and outputs the frequencies on the serial monitor. Amazing!
Avec Conto, ouvrir un compte pro en ligne ne prend que 10 minutes. La gestion de...
Let's get into programming now. A few lines of C code are actually enough to tune into a radio station. After installing the library and including the header file, just get an instance of the RDA5807 class, then initialize it, wait a second for the setup to finish, then set the frequency you want divided by 100 and that's it. Compile and upload, there we go. You can still make your radio better. Mono makes sense if you have only one speaker. And it improves the sensitivity. If you want to use a radio outside the US, setting the DM phases to 50 microseconds makes it sound less muffled.
And small speakers sound less like Mickey Mouse
when bus boost is enabled. But the thing that's still missing there is a user interface. User interfaces for this kind of devices can easily be realized with the LVGL library. LVGL is an abbreviation for Light and Versatile Graphics Library. This library is supported by many ARM or ESP32 based boards, including the WIO Terminal. It offers a good choice of widgets, which with appealing user interfaces, especially for small low-resolution devices, can be created. So I made one from my RDA5807 receiver. We can control it with a little joystick, which makes scanning from station to station, as well as directly entering the frequency possible. And also the volume, of course. I'm going to mute it now to not run into copyright issues. On the configuration page we can choose the frequency band and also the space between the stations. 100 kHz is perfect for FM broadcast, but for playing around there are also other values. Right below there are the settings I described earlier in this video. Checking USA changes the emphasis to 75 microseconds and activates the North American RBDS instead of RDS. The 5807 supports both RDS and RBDS. The messages I get in are somehow screwed up though. I don't know what's going wrong there, the signal should be strong enough. Perhaps my particular 5807 is just crap. Anyway, maybe anyone can tell what's going on and write it in the comments. For now, I leave it as it is. If you like, you can put this simple circuit on a proper circuit board and handcraft or 3D print a nice enclosure for it. Source code and schematic are linked in the description. I'm at the end for now, so all there's left to say is thanks for watching and see you next time.